All right, guys, so we're going to go ahead and continue doing this. This time we're going to do 3/4 is what they want us to do. So this one's going to be a little bit more tricky on here. So first of all, what I want to do is I want to show 3/4 on a number line. And if I make my number line, I always want to start with 0 and 1 because I have not gone over a whole. Because remember, my whole is going to be 4/4. So I'm going to make 1/4. Remember, this is 0/4. You're going to make 2/4. I'm going to make 3/4. And then this is actually equal to that 4/4. And to show me where 3/4 is, 3/4 is right here on the number line. Now, you could have ended with 3/4, or you could have gone ahead and continued on and just shown that 1. But we definitely want to make sure that when it's asking continue the pattern with 3/4, that I want to show that this is where 3/4 is. So what I'm going to do is each one of these fractions, I'm going to go ahead and show 3/4. So I have 1, 2, 3, 4. So each of these little boxes I am going to turn into fourths. Now, the only difference is because on the front side I started with 1/4 or 1/2. This side I'm actually starting with 3/4. So if I'm starting with 3/4, how many should I have shaded in? And if you said 3, you are correct, because I need to show this box, these fractions right here, I need to show them as 3/4. Okay, this just kind of goes back to, you guys are already aware of this, you guys have already seen this, that I've got 3/4. Oh, let's write 3/4. Okay. So what we're going to do is we're going to continue on how we're going to do this to create equivalent fractions. So they're going to be the same. So what I'm going to do is I'm going to draw one line across. Okay. So now what I've done is I've multiplied that fraction by 2 because I have 2 parts. So I'm going to take my numerator times 2 and then my denominator times 2, and I get 6. So 3 times 2 is 6, 4 times 2 is 8. Guys, if you count that up, it should be equal. This next one, because I did this one by 2, if you guessed it, I'm going to make that into 3. So I've got 1, 2, 3. So what I now need to do is I need to multiply each of these by 3. So I'm going to do 3 times 3, 4 times 3, and I get 9/12. I'm going to do 4s now. 1, 2, 3, and 4. So 1, 2, 3, 4. I'm going to multiply then my numerator times 4 and my denominator times 4, and I get 12/16. Okay, all we're doing, guys, is we're creating equivalent fractions because 3/4 is equivalent to 9/12. 3/4 is equivalent to 6/8. 3/4 is equivalent to 12/16. If you guys wanted to, you could draw 10 lines in here and multiply the numerator by 10, the denominator by 10, and you're still going to get the same equivalent fraction. I'm just making it easy on myself, and I'm only going to kind of go split it into 2s, then 3s, then 4s, and then 1, 2, 3, 4, and 5s. So now I can take 3 times 5, I can take 4 times 5, and I get 15/20. Okay. Number 4, little tricky. Okay. The reason is, guys, is because it says that we've got to continue the process and we're going to model only 2 equivalent fractions. But look at this. This says 6/5. Okay, if you think about 6/5, that is actually an improper fraction, and if I were to simplify it into a mixed number, it would actually be 1/5. All right, so when we are doing this, guys, you have to remember that you've got to look at your fractions. You've got to find those, make sure that the fractions are written in its simplest form, but then you also need to make sure that if you have an improper fraction like this, we probably need to turn it into a mixed number. So what that's going to tell you, guys, is you're going to have my model is going to start at the number 0. I'm going to have the number 1, but I'm going to have to continue on. So I'm going to show 0/5. I'm going to show 1/5, 2/5, 3/5, 4/5. 1 is going to be 5/5 is what that equals. And then right here is going to be my 6/5. fifths, or my 1 1/5. So this one, guys, you have to make sure that you are always watching and plotting if I have a mixed number. Now, if you guys notice, my numbers aren't necessarily like perfectly the same. I'm not going to worry that your number line looks perfect. As long as you have the fractions where they need to be and the correct amount, you are fine. So then this is where it comes down to, I need 2 models for showing me 6/5. So each of your models should be split into fifths. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I'm going to do the same thing over here because I am going to have to do this in fifths. Okay, so what we're going to do right now is, because it says 6/5, I want to count 6. So here's 1, 2, 3, 4, 5. I have to go into that next model. So there is my 6/5. Same thing here. 1, 2, 3, 4, 5, 6. I have to show that 6/5. And when I'm doing my work here, that is completely fine to go ahead and have those 2 models. So what I'm going to do, just because I want to make it easy on myself, is I'm going to split this one into halves. So I have 1 and 2. So what I'm going to do is I'm going to take my numerator, multiply it by 2, and I'm going to take my denominator and multiply it by 2. And so if I were to look at this, what I have now with 6/5, I actually have 12/10. Okay, so if you look at that, how many I have, and you're probably sitting here thinking, but wait a second, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I have 20 altogether. No, your fraction is the fifths. Even though I have a fifth here and I have a fifth here, it's all going to be the same fraction. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of my tenths. So I'm going to do the same thing here. I'm just going to do it by 3s. So I'm going to show 1, 2, and 3. So I'm going to multiply 6 times 3, and then I'm going to multiply 5 times 3. And if I do this correctly, I've got 18/15, and if you add that up and count that up, it is going to be equal. So remember, guys, we are doing equivalent fractions. When it gets into a mixed number like this, you have to show me that one whole and then what you have left over.